Hey guys, welcome to day 48 of Codeforces Every Day until GM. Just jump straight into it. We are back on the ADC ladders. Gonna do problem number 3, contrast value. Gonna hope to do 3 problems today. Hopefully each of these problems don't take me a bajillion hours. Oh, there is a contest tomorrow, right? I still haven't registered for that. I should probably do that real quick. It is 25th. It's gonna be 8:30 in the morning, so I need to wake up early for this. Oops, didn't mean to do that. Not Kotlin Heroes. Register. Yep. Register. Okay. And I'll be doing that contest. I'll probably also do this Div 3 here. Should have time on the 27th too, but we'll see. Okay. Well, we signed up for that. Let's just jump straight into problem solving. This is a 1200 rated. And here's the problem. For an array of integers, we call the value, let's call the value absolute value the contrast of the array, okay? Note that the contrast of array size 1 is equal to 0. You're given an array of integers A. Your task is to build an array of B in such a way that all the following conditions are met. B is not empty. B is a subsequence of A. B can be produced by deleting some elements of A. The contrast of B is equal to the contrast of A. What's the minimum possible size of array B? Okay, T, test cases equals int input. And then for underscore in range T, first line of each test case n equals int input, and then we take in an array, right? So A equals list map int input split. Dude, I keep hitting the most random keys. Alright. So what's going on in this problem? Print a single integer, the minimum possible size of the array B. Okay. Build an array B such that all the following conditions are met. B is not empty. B is a subsequence of A, meaning B can be produced by deleting some elements from A, maybe 0 elements from A. So B can be equal to A. The contrast of B is equal to the contrast of A. Okay, so it seems like this problem should have some sort of pattern. It's a greedy implementation. So what does that mean? We want minimum possible size of B. So can we sort it? I'm thinking like right now, just from minimum and subsequence, we want to kind of like pop elements into A or into B. Like we're given A, B equals this, and then like we iterate through some, and then we do like B dot append. Now the question is, how do we append? Do we need to calculate the contrast of A? Because the contrast of B is equal to the contrast of A, so we will need to know the contrast of A, right? Or here's another possibility. Since we're like this, we don't have to reorder at all. I think we just check for cases where A2 minus A3 equals 0. Or like, yeah, since they're absolute value, it's like when the two numbers, like the contrast is equal to A1 minus A2 plus A3 minus A4 plus dot dot dot, right? So basically, when we can find a contrast is when one of these are 0, and then after 0, we can remove it from A. So we can do B equals A, actually, and then we remove elements. That sounds like a more plausible way to do this. Now, this also means that, this is 2, 3. Okay, so this is a good catch. I almost said that this also means that the array is always even, but no, it's 2, 3. So basically we're checking if any two numbers is equal, right? Okay, so let's take a look at the test cases. 2. What are the minimum possible size of the array be? So since these are equal, we pop these out. Well, no, there's 3 next to each other. So 1, 7 is a subset of B. Okay, what is the contrast of 1, 3, 3, 3, 7? 1, 3, 3, 3, 7 is 2 plus 0 plus 0 plus 4, which equals 6. Contrast of 1 and 7 is 6. So what does this mean? If they're equal, we just get rid of them? So we're just left with 1 and 7? Or I'm also wondering about cases where it's like we can get 6, but also it's like you don't have to get rid of stuff, but you want to get rid of stuff if you can. So, will the contrast ever get... So, okay, say we have 1, 3, 3, 3, 7, and we try getting rid of 1. Well, the contrast equals 6, obviously. We try getting rid of 1. Then we check. This is 0, 0, 4. Since they're not equal, we cannot get rid of 1. So we try getting rid of 3. Then we get 6. So we can get rid of 3. So instead of trying to get rid of just one number, we can try to get rid of all like duplicate numbers. So like since this is 3 3s, like we check 1, since there's no 1s next to it, we just try 1. But and we check 3, there's 3 next to it. So we just get all of these. We remove all of these and then we move on. And then we try getting rid of wait. If we do get rid of one group, we're basically asking, can we get rid of more? Or can we get rid of different combination? No, because in this problem you can never get values back. Right? Well, 1, 3, 7, we get 2, 6, which is 8. 173, we get 6, 4, which is 10, but if we remove 7, we get 2. So no, I don't think we can ever end up with a higher number by removing numbers. Because we're just removing an addition. But what if that addition adds a lot? Well, each number, unless it's a side number, serves as 2 additions. But it's also subtraction. But it's absolute value, so it's not really a subtraction. What if it's like a wide gap, like a 9 and 1? Then this serves for 8. But then we have like 991, which is 0. Or maybe like 891, which is 1. So we can separate these a little bit. And then we remove 9, which will only leave us with 8. So what about like 101? Leave us with 2 ones. We would remove 0. We'll left up with 0. So no, I don't think you can remove and then gain. So removing, and since it's greedy, I don't want to be blinded by this greedy tag here, but it just further supports the idea that removing will always decrease the value of the contrast. So now we need to build an array of B. 4, 2. The contrast of 4, 2 is 2. What is the minimum length that it can be? The minimum length it can be is 2, right? Because then you can't find the contrast of a single element. So, first of all, if len A equals 2, print 2, continue. That's that case. Or instead of doing this, we can do in. Now, thing is, I don't really know how to remove stuff yet. Subsequence, it means we can't rearrange, but we can delete stuff. Wait, this one outputs 1. Case 3 outputs 1. Why? 0. So B is one element, which means the only thing it can be equals to 1. What does that mean? Oh, note that the contrast of an array size 1 is equal to 0. That's good to know. So this is not even an edge thing. Because for this case it's just 4, 2. Five, 4, 2, 1, 0, 0, 4. Is 3. Because contrast is 1, 2, 3, 4, 5, 9. Contrast is 9. So what can we remove to get 9? 9. We can make 9 with 2 numbers from this. Oh, that might be the correct kind of thinking. Maybe. Like, I'm thinking of LeetCode 2 some right now, where you hash the it's like, okay, so we have a contrast, and then we have a box of elements. We basically greedily pick the biggest element, and then we remove it from the box. Then we have C minus that element. So I just call this L. C minus L. And then we continue with, call this L1. This box. Then we keep choosing the biggest element. No, that doesn't work because of overflow. If we had 12, or what is the contrast of 1? It's 6, right? Our contrast is 6. So what the hell is the play? First things first, I think there should be like a cleanup phase where if there's like duplicate elements in a row, you squish them all together. Like a collapse function. But I'm wondering if that'll take up too much time. This is tricky. I don't even know where to start to think. Like, I have a few different pathways, but they all don't seem like right. Um, what do we know? We know that removing points will never increase. Let's write that down. Let's write down what we know. Removing points will never increase contrast. Okay. So pairs or like duplicates. Removing duplicates does not change contrast. Okay. Removing duplicates does not change contrast. Uh, Actually it does. I think I'm blindsided by this because doesn't this give you a 0 and a 4 to play with, and removing the zeros will 5R21004. 1, 2, 1, 1, 0, 4, 4, 5, 6, 7, 8, 9. 1, 2, 1. 1, 2, 1, 3. 2, 3, 4, 5, 6, 7. But if I had one more 0. Hello? 1, 2, 1, 1, 4, which would equal 9. So, okay, we need to look at case 1, 3, 3, 3, 7 again. 2, 0, 0, 4, 7. Wait, it's 7. Why did I think it was 6? Two, 0, 0, 4. Oh, it is 6. I just can't count. 1, 3, 7 is 2, 4. It is also 6. 1, 7 is also 6. Okay, so This makes it a little less good. So what's happening here? It's just that some cases it might happen to be the same contrast. Okay? Uh, what else can we delete? Because we're obviously deleting more shit here. We're deleting 1, 0 max. 5, 4, 2, 1. Well, okay, let's take a look at this. So A1 minus A2 plus A2 minus A3 plus A3 minus A4. There's probably enough digits to play with. Is there any math? We have 1 A1, 2 A2s, 2 A3s, and then 1 AN. A1 minus Well, actually, these can cancel out somehow. Because this is minus and this is plus. So A2 plus A1 can be null as well. But they have to follow a specific pattern to be removed. What is that pattern? If say 1, 1, 3, 3, 7 doesn't really work. 1, because let's do 1, 3, 4. 1, so we get 2 here, and then we get 1, 3, and then we remove, if we remove the middle, we also get 3. Wait, 1, 3, 7, 2, 4, 6, 1, 7 is also 6. We looked at that one earlier. So is anything with 3 in the middle? Like 1. But what about 1, 4, 5? This is 3, this is 1. Or just 4, okay. Wait, there's some pattern here. Some pattern going on here. 1, 4, 6. 3, 2, 1, 6. Does the middle matter? 1, 9, 1. 8, 8, 16. But no, that doesn't work. 16 and 0. This would be the same. So, okay, so, well, first of all, this number has to be greater than this number, right? What if this number is greater than this number, actually? It's just case 1. If it's 1, like 8, 9. This is 7, this is 1, which is 8. This is also 8. That works. 1, 8, 9, 7. 8, 2, 10, and then this gives us 6. No, that doesn't work. Okay, so this works. Why does this work? Does the flip work? 9, 8, 1 is 1, 7, 9, 7, or 9, 8. It does work. Okay, so it looks like any orientation, or like, well, this orientation and the reverse of the orientation. So there's 2 here. And it's increasing order, right? 1, 3, 4, 1, 4, 5, 1, 8, 9. This doesn't work. This doesn't work. Backwards works. Okay, so it's increasing and decreasing order. 3 numbers in increasing and decreasing order, we can pop out like the middle terms. And then at the end we can just len b. So first we need to collapse. We need to somehow collapse A. So is there like a way to Python collapse lists? That's not what I want. Python what do I even search? Like I think about like collapse list. Like it's technically it's like an accordion. You just squeeze everything together. Right? But let me think. No, that's not what I want. Yeah, consecutive duplicates. That's the word I was looking for. Itertools group by. Python. I spelled buy like I'm buying something. Itertools group by. Take a look at this. Was okay, so like for key and group itertools dot group by. So first of all, let's import itertools. And then for key, what does, how is it, okay, it's like group, print group, itertools dot group by, can I, okay, from itertools import group by. Group by A. Like, what does this actually output? Whatever this is. Is it a dictionary? Like, can I do group by A3? Not subscriptable. What exactly is group by? List. Oh, I can list it. One itertools group by object. 3, 7, 4, 2. Okay, well, I think it's working. So, what is itertools group by object? 4. Generates a consecutive group of consecutive elements from an interval and returns them as tuples containing a key and a group. Ah. So like a key for key group in group by. Hey. B dot append key. Print B. Oh, yo, yo, we're getting somewhere. If len b equal 1, print 0. Print 1. Continue. Because contrast array size 1 is equal to 0. Now, we look through and we do for I in range, start at 1, go to n. If b I minus 1, b I, b b I plus 1, or swap the signs, b dot remove first current to the value, that's not what I want, dot pop I. Then we just println b. Index out of range, n minus 1. Index out of range. Ah, I understand. It's not n, it's len b. Two, two, one. And somehow we have removed every value in the last array. How? 5 or 2, so we can remove 4. Right? It's 1, 3, or 1 and 2, which is 3. 5, 4, 2, 0, 4. Kill him. 5, 2, 0, 4. Oh, I see why this might not work. Because now we have to start from the beginning again. We kill him. 504. Okay. While I n equals 1. Well, I is less than n. Else I plus equals 1. It's sure. Nothing's coming out now. Index out of range. One through 7. N is 5. Once again, it's not N, it's len B. This still runs into index error because I need a len B minus 1. 2, 2, 1, 3 looks like. There we go. This should be it. It's taken me 48 minutes. Okay. TLE is Jover. I'm about to FF myself. I am literally to the end, bro. I guess I gotta research every time. Keep running in here over and over again. What if we can just check if this, check if this, and then start iterating from here so we can kill. Wait, so we can I. Okay, so basically this is our I. If lesser, kill, set new I. If lesser, kill, set new I. Doesn't work anymore. Oh. What is this question? It's messing me up. Well, okay, it's probably dot pop. Oh, and instead of pop, don't pop it. What if I just count it? These will always count. Right? So we start here. Check this. If so, that's a count. We don't actually need to remove it because then we know this is greater. So then we go here, check this, add to count. Go here, check this, doesn't work. And at the same time, we can check the other way around. So if either way works, then we add. So we don't need to pop. We actually need to do a toPrint equals 2 because we always have the ends. And then while I is less than, well, toPrint is less than, we do toPrint plus equals 1. Wait. No, this isn't right. Well, toPrint, this part is right. We can do toPrint plus equals 1. And then instead of having this, we can have a for loop. And it's like here for I in range from 1 to len b minus 1. Something like this. 3216. Oh, we're printing len b. We need to print toPrint. 3215. That doesn't change much. Failed to see where 5 is coming from. Okay. So doing it like this, technically we count the ends and we count when it gets messed up. Here. So 137, we count the ends, and it never gets messed up, so we don't add anymore. 1. No, that's not a good case. In any case, like 13542. Right. We count the ends, and then where does it get messed up? No. Boom, messed up, so we add 1. and then 5, 4, 2. No, that's not messed up. So we have 3 here. Right. Yeah. Okay, so what actually needs to happen is to check if like this. There we go. Bro, I'm cooked. These questions are really hard. The new gen questions are so much harder than the old gen ones. It's 1200 rated. I'm thinking about lowering the difficulty next time. What do y'all think? Because this one question took me an hour. Maybe we'll do 1100s, but yeah. I'm just gonna call it here. I have some homework to do. Want to leave time for that. But if y'all enjoyed this video, be sure to like and subscribe, and I'll see you guys tomorrow. I will go back and bookmark this question for review. I still want to do like a big review day where maybe I'll have like a buddy or something. I have a few friends, and then we can race. Like he's higher rated than me, so since I've seen the questions before, like I'll have an edge. But like since he probably hasn't seen the questions before, then we can compete to see who solves it first. That might be a good video idea. So let me know if y'all want to see that. But if y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow. Bye.